Question 1. Question 1 asks how can electric cars be described as A. A positive consumption externality, B. A positive production externality, C. A negative consumption externality, D. A negative production externality, or E. Both A and B. There are some key phrases within the answers that need to be defined in order to gain understanding and how accurate the descriptions are for electric vehicles. The major term that we need to know is externality. The textbook defines an externality as the uncompensated impact of one person's actions on the well-being of a bystander. Put simply, the unintended impact on an individual or society. A perfect example of this is the use of petrol and diesel-fueled cars and trucks. The drivers of these vehicles do not have the intention of emitting pollutants to the air, which then causes illnesses to those peoples within the atmosphere. It is purely unintended and subsequently uncompensated. Another set of phrases is positive and negative. These are the verbs of the word externality. They purely describe whether an externality is good or bad. As in the example I spoke about earlier, the cars and trucks polluting the air can be seen as a negative impact. Thus, cars and trucks would be described as a negative externality in this instance. However, they can be seen as a positive externality in the sense that these vehicles move people and goods to places more quickly. The final set of phrases are production and consumption. Production, as we know, is the manufacturing of raw materials in order to create a final product, which leads us on to consumption, which, as we know, is the act of using the product or resource. These phrases and words are put together into our answers. So, we know that electric vehicles do not emit damaging pollutants into the atmosphere, as supported by the article, as it claims that electric cars will enable and accelerate the greening of the grid. This then establishes that electric cars, when used and consumed, can be described as a positive externality. So, this automatically creates the informed decision that A is correct. Also from the article, we learn that costs, materials, electricity disposal, tend to be relatively easy to quantify, and that the grid is rapidly greening. We know batteries are rapidly getting cheaper and better. We know EVs are at the front end of a long innovation curve. Therefore, it is clear that from this that the production of electric vehicles does not showcase a negative externality, thus a positive one. From the answers then, we can clearly indicate that the answer is not C nor D. However, A and B are of true nature as to how electric cars can be described. Thus, the answer to the question is E.
Question 2. Question 2 states that according to the article, economic research finds that the environmental benefits of electric vehicles are, for now at least, marginal and worth less than the subsidies paid for them. The article then describes electric vehicle subsidies as excessive and inefficient. The question then asks, which graph about the electric vehicle market best represents this statement? Here are our 4 graphs. Let's deconstruct each option in order to allocate the most appropriate answer. Graph A suggests that the social marginal benefit of electric vehicles is quite extensive due to its large shift to the right of the private marginal benefit line. The per unit subsidy line is located between the private marginal benefit and the social marginal benefit lines, thus explaining the fact that the social marginal benefit is exceeding the per unit subsidy. Essentially, Graph A contradicts the article's statement that these benefits are worth less than the subsidies paid for them and that the subsidies are excessive, making this graph incorrect. In Graph B, it is evident that both the social marginal benefit and the per unit subsidy lines have equally shifted the same distance to the right of the private marginal benefit line. This highlights that the social marginal benefit is just as effective and worth the same as the per unit subsidy, making Graph B an incorrect representation of the statement. Graph C is rather different in comparison to Graph A and B. This is due to the fact that the per unit subsidy and the social marginal benefit lines have shifted left rather than to the right of the private marginal benefit line. Immediately, this makes Graph C an incorrect option. The reason behind this is that shifting the lines to the left suggests that the per unit subsidy and the social marginal benefit are detrimental factors towards the private marginal benefit. Furthermore, the article states that the environmental benefits of electric vehicles are for now marginal, however worth less than the per unit subsidies. The use of the term marginal suggests that there is a minor environmental benefit which is not clearly represented in Graph C. Instead, it has been represented as a negative factor rather than marginally beneficial, whereby the per unit subsidy and the social marginal benefit lines should have been shifted to the right of the private marginal benefit line, making graph C an incorrect option. We are then left with graph D. As graphs A, B, and C have been incorrect, it is evident that graph D will be the correct option. Let me explain why. The social marginal benefit has only shifted a slight distance to the right of the private marginal benefit line, which essentially represents its marginal environmental benefit. Furthermore, the social marginal benefit line is located to the left of the per unit subsidy line, which continues to support the statement that these benefits are worth less than the subsidies paid for them. The statement continues to claim that these subsidies are excessive and inefficient. Shifting the per unit subsidy line further to the right of both the private marginal benefit and the social marginal benefit lines clearly represents this statement, thus expressing these factors as playing a vital role in making graph D the correct representation of this statement.
Question 3. Question 3 states, Robert recognises that climate change is significant enough to warrant transferring consumer demand from oil to electricity. Suppose that, using these subsidies, consumers substitute towards using electric cars and away from cars that run on petrol and diesel. Which graphs best represent what will happen in the electric car market and the general car market? We are presented with 4 graphs, and these are our options. Graph A for the electric car market presents to us an increase in the demand for electric cars, thus increasing the price and the quantity demanded and sold. We are told that the demand for electric cars rise as a subsidy is placed on the consumer. One reason for this could be the implementation of tax rebates to those who purchase electric vehicles, thus increasing consumer demand, which is evident on the graph. In contrast, the general car market in graph A represents a decrease in demand as the subsidies entice consumers to shift their vehicle choice from cars that run on petrol to electric vehicles. What we are shown in this graph is a correct representation of what would happen in the market, as electric cars and general cars are substitutes. Thus, the increase in one would reduce the demand for the other. Therefore, graph A is a correct representation of the changes in the car market. The general car market in graph B is the same as in option A, which makes this diagram a correct representation of the effect of increased subsidies in the car market. In the electric car market for graph B, we are shown a downwards movement along both the supply and demand graph. We are told that the quantity demanded of electric cars increases. However, this is not represented on the graph, and therefore graph B cannot be correct. Similarly, in graph C, the general car market graph is the same as in options A and B, and therefore is a correct model of subsidies being provided to reduce demand for general cars. However, the graph for the electric car market is incorrect, as a subsidy placed on either a consumer or supplier would lead to a shift in demand or supply respectively. On the graph, we are shown a movement along the curves, which is not the correct effect of a subsidy on the market, as a subsidy will lead to increases in market demand or supply. Thus, graph C is incorrect. In graph D, the graph for the electric car market is the same as that in graph A, which makes it correct. However, the graph for the general car market is incorrect. We are told that electric cars and general cars are complements for each other, which would lead to an increase in demand for general cars when a subsidy is in place. This is incorrect, as electric cars and general cars are substitutes for each other, and an increase in subsidies on electric cars would reduce demand for general cars. Therefore, graph D is incorrect, along with graph B and C. That being the case, graph A is the most correct answer.
Question 4. Question 4 asks, do you think a target-based policy would be better than a cost-based policy? Why or why not? As a group, we agree that a cost-based policy would be more effective than a target-based policy in accordance with the following reasons. Firstly, let's define these two terms.
A target-based policy is one which allocates a set number of goals over a period of time by the producer or government. These goals are prioritized over the private cost and therefore focuses upon the success of a product in accordance with these set targets.
On the other hand, a cost-based policy is one which follows the principle that the direct costs and other economic variables need to be outweighed by the benefits in order to reduce or eliminate negative environmental externalities. For example, the environmental benefits would need to exceed the cost of producing an electric vehicle.
Last year, Australia became a signatory to the Paris Agreement, requiring the development of long-term decarbonisation strategies to be achieved by 2050. Research by Climate Works Australia suggests that the transport sector of the economy represents the most financially attractive emission reduction opportunity across the Australian economy. The transport sector contributed for 17% of emissions in 2013 and 2014.
Car manufacturers can help achieve these targets through increasing their production of electric cars. In 2011, AECOM conducted research on the Victorian market and it found under their modelling, air pollution would be reduced by 10,000 tonnes by 2030, as well as an additional $5.5 billion in wider economic benefits.
Based off this, we can conclude that a cost-based policy in relation to electric vehicles would be better than a target-based policy. Under a cost-based policy, the government can incentivise producers of cars to produce electric vehicles by offering them subsidies to help reduce the production costs.
Furthermore, the government can use taxes as a disincentive for producers to move away from general cars. Taxing the externality, in this case the pollution emitted from the general cars, would lead to the price of general cars increasing, reducing their demand. Consequently, offering subsidies would reduce the price of electric vehicles, thus increasing their demand.
A target-based policy surrounding electric cars wouldn't be as effective due to the fact that it is difficult to enforce these targets. However, a specific cost-based policy focused on electric vehicles used in conjunction with a more general target-based policy can be very effective in helping to reduce carbon emissions.